Hey everybody. Today we're doing some unit circle trig. For angles between 0 and pi over 2, we can define trig functions like sine and cosine by drawing right triangles. And then sine of theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, and so on. Unit circle trig lets us extend those definitions to any possible angle. The unit circle is a circle of radius 1 whose center is the origin. Its equation is x squared plus y squared equals 1. For any angle theta, we can draw that angle in standard position so that its initial side is on the positive x-axis. And it'll pick out exactly one point on that unit circle. We'll label it x comma y, and then draw a perpendicular to the x-axis, giving us a right triangle. Notice that the hypotenuse of that right triangle is always going to be 1. If theta is in the first quadrant, so if it's an acute angle, then in fact, cosine of theta adjacent over hypotenuse is going to be x over 1. Sine of theta, opposite over hypotenuse, is y over 1. And then tangent theta, the ratio of those two, is going to be y over x. If theta isn't between 0 and pi over 2, radians that is, we can use those same formulas just to define sine, cosine, and so on. So here are the formulas. Cosine theta is x, sine theta is y, tangent theta is y over x. Secant, cosecant, and cotangent theta are just the reciprocals of those. Okay, let's just jump in with an example. Find the values of each of the 6 trig functions for 5 pi over 4. Here's that angle drawn in standard position. It's a half turn plus another 45 degrees. Our task here is to find the coordinates of the point x comma y. Here I've drawn that perpendicular line to get a right triangle. Notice that the angle is in the third quadrant, so the coordinates of both x and y are going to be negative. This triangle that I've drawn is an isosceles right triangle because that angle that I've labeled with gray there has to be pi over 4, 45 degrees. So the legs of that triangle have to be the same length. Let's call that length A. By the Pythagorean theorem, a squared plus a squared is 1. And so a is the square root of 2 over 2. Because this angle theta is in the third quadrant, both x and y have to be negative. Those coordinates are both negative in the third quadrant. So x is negative root 2 over 2, and y is negative root 2 over 2. Now we can use the definitions that we had a few slides ago to write down the trig functions of the values of the trig functions of 5 pi over 4. Cosine theta and sine theta for theta equals 5 pi over 4 are both negative root 2 over 2. Tangent theta is 1. Secant, cosecant, and cotangent theta for 5 pi over 4 are the reciprocals of those first 3. The signs of x and y are completely determined by the quadrant of the angle theta. X, for instance, is positive in quadrants 1 and 4, and y is positive in quadrants 1 and 2. Since x is cosine and y is sine, that lets us know the signs of all the trig functions in the different quadrants. For instance, cosine theta is going to be positive in quadrants 1 and 4, and sine theta is going to be positive in quadrants 1 and 2. There's a simple mnemonic to help remember where the different trig functions are positive. ASTC, all students take calculus. Sometimes you'll also hear a smart trig class. In quadrant 1, all 4 trig functions are positive. All 6 trig functions are positive. In quadrant 2, sine and its reciprocal are positive and the others are negative. In quadrant 3, tangent and cotangent are positive and the others are negative. And in quadrant 4, cosine and its reciprocal secant are positive, and all the others are negative. Let's do one more example. Find all 6 trig functions of the angle theta equals 3 pi over 2. Here's a picture of that. We can see it is a 270 degree angle, a 3/4 turn. In this case, we can see the point xy on the unit circle that's defined by this angle just by inspection. It's going to be the point 0, negative 1. So the cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is negative 1. And the tangent of 3 pi over 2 does not exist. Y over x, negative 1 over 0. The secant of 3 pi over 2 doesn't exist. The cosecant of 3 pi over 2 is -1, and the cotangent of 3 pi over 2 is 0. All right, so we notice that there's some values that are not in the domains of all of these trig functions. Let's delve into that a little bit more. We can determine the domains and ranges of all 6 trig functions just by looking at their definitions. Cosine theta and sine theta are going to have ranges, or rather are going to have domains, all real numbers. Because for any angle theta, we get an x and a y value. For secant and tangent, the domains are going to be all real numbers except the ones that make the denominator 0, that make x 0. So tangent and secant are going to be defined for all angles except pi over 2, 3 pi over 2, 5 pi over 2, and so on. Pi over 2 plus k pi, where k is any integer. Similarly, the domains of cosecant theta and cotangent theta are all real numbers except the ones that make y equal to 0. So multiples of pi. The ranges of sine theta and cosine theta are -1 and 1, and the ranges of secant and cosecant theta are all real numbers whose reciprocals are between -1 and 1. So the numbers that are bigger than 1 in absolute value. Finally, the ranges of tangent and cotangent are all real numbers. All the basic trig identities that you learned when you're studying right triangle trigonometry carry over here. The reciprocal identities, I already alluded to those earlier in this vid. The quotient identities, tangent theta is sine theta over cosine theta, and cotangent theta is cosine theta over sine theta. And the Pythagorean identities, in particular sine squared theta plus cosine squared theta equals 1. But many additional identities become possible when we allow angles that aren't just between 0 and pi over 2 radians. First of all, periodicity. All 6 trig functions are periodic. They repeat themselves. Sine and cosine have period 2 pi, so whenever you add or subtract 2 pi or any multiple of 2 pi from your angle, you don't change sine or cosine. The same is going to be true for cosecant and secant because they're just the reciprocals of sine and cosine. Tangent and cotangent have shorter periods. It's only pi. One additional useful fact, changing the sign of theta changes the sign of the y-coordinate of the terminal point. So the effect is to reverse the sign of certain, but not all, of the trig functions. Sine of negative theta is negative sine theta, because of course sine theta is the y value. Similarly with cosecant. Cosine, on the other hand, of negative theta is equal to the cosine of theta, and the secant of negative theta is equal to the secant of theta. Simply because cosine deals only with the x value. And the x value is not changed when we change the sign of the angle theta. Tangent and cotangent have the same property as sine. In words, we say that cosine and secant are even functions because replacing theta with negative theta does not change the value of the function. The other 4 trig functions, sine, cosecant, tangent, and cotangent, are odd functions. When you replace theta with negative theta, you change the sign, sign, of the function. Let's conclude with a couple of examples. Let's compute tangent of 17 pi over 4. So the idea here is to use periodicity. We're going to find an angle coterminal with 17 pi over 4 where it will be easier to evaluate this trig function. So I'm going to take 17 pi over 4 and subtract 2 pi, that is to say 8 pi over 4. Do it again, and then evaluate tangent of pi over 4 just by picturing an isosceles right triangle. The answer is 1. Second, let's do cosine of negative 15 pi over 2. Again, I'm going to start adding multiples of 2 pi until I get to a more convenient angle. So here I'm going to add 16 pi over 2. That's 8 pi. It's a multiple of 2 pi. So I'm really just looking for the cosine of pi over 2, and that's equal to 0.